Well, let's take a little look at dark matter here. There's an article about the lumps in space, which it shouldn't be if the space is going by the normal Big Bang thing. Simulating the universe using Einstein's theory of gravity may solve cosmic puzzles. See, they have some puzzles in their theories, and so they've had to make up stuff like dark matter, which may exist, but not as much of it as they need for the universe to turn out like they want it to, according to their frames of mind, and dark energy, which is totally here. Take a look at this. It says here that the expansion of the universe, the accepted explanation, doesn't mean it's right, for the expansion of the universe is invisible pressure called dark energy. Now, the head of the physics department at Yale said dark energy is code for we don't have a clue, which I'm glad that she admitted that. I've always thought that was very honest. But it's not so bad that they're making up this stuff. What's bad is they and everybody else are letting on that, whatever we make up is real. That's not science. It's actually kind of, what do you call it? Insanity. We don't want to be guilty of that in science. Losing touch with reality. So it says here that, it's trying to focus, that dark energy makes up about 70% of the universe's stuff. Yet scientists still aren't sure what dark energy is. And finding its source is one of the most vexing problems in cosmology. Well, they have a lot of problems in theoretical astrophysics. Okay, let's see here. Simulations rely on these approximations. The Drake equation, for instance, is just 7 guesses multiplied together, and they put an equal sign after it, as though putting an equal sign makes it true. That's a little fairy tale-ish too. I mean, I don't have anything against Drake, but let's not say that it's a real equation. Here we go. Telescopic images. We need accurate simulations. I'm thinking white hole cosmology would be accurate. Lumpiness is behind a puzzling mismatch of 2 estimates of how fast the universe is expanding. That was helped recently by the neutron star collision gravity waves that helped give a better estimate on what was really happening here. So, do the lumps in the universe matter at all? This one guy from University of Chicago says, it haunts me. I can't let it go. They're worried about predictions that can be compared with actual observations. That'd be nice. Let's see. Here we go. Accelerating of the universe. Exploding stars. Gravity would slow the expansion, you'd think. So to account for the observed acceleration, which is a fact, scientists needed another ingredient to the universe. So they added dark energy. They needed something to explain the universe, so they just made this up. They just added it to reality, and isn't that something? I hope they will continue to admit that. So, many cosmologists follow a basic recipe to simulate the universe, treating a cosmos as if it's been run through an imaginary blender, smooth out its lumps, adding dark energy, and calculating the expansion via general relativity. Now, relativity has been proven experimentally and evidentially, but this dark energy and this other stuff about the Big Bang has not. That's just pretend. So then they add the lumps. They just pretend it. Then they add in these approximations. Newtonian gravity is good for big things, but not for the twisting of space. Let's see. And all of these models that are in the Big Bang paradigm, in basically the atheistic, materialistic, naturalistic paradigm, for how the universe had to come about. All of these, and you could read these things and the questions I asked about them if you wanted to freeze it up and all of that. But all of this stuff is so hypothetical, and that's nice, but people are taking these, whatever comes out of the imaginations of these physicists, they're taking it as being real. There you go. Predictions based on the standard framework agree with observations. And we're talking about the cosmic background radiation. That's nice, something agrees with observation. But dark matter must exist to explain things that would otherwise be embarrassing to cosmologists. Wow, it must be hard when you have egos that big that you're embarrassed that you don't know everything. I'll say there are exceptions, like that chair of physics at Yale. They're not embarrassed. They're just like they thump their heads about it, but they're not going to be embarrassed. Dark energy. Let's see. The theories that include dark energy can explain the universe extremely well. How could that be if the whole approach is flawed, though? Yeah, that's true. What if dark energy is not real? Now what are they going to do if this imaginary thing they've invoked actually isn't real? Well, it certainly couldn't work if it wasn't real. So they're trying to use general relativity. They're thinking that maybe that will give them better answers, even though it's super complicated to calculate compared to Newton's stuff, which is basic high school physics. Let's see. They've not been able to account. The simulations can't account for the acceleration using relativity. And so they're trying to explain away the need for dark energy by using relativity, but it's just very complicated is the problem. Well, the universe is complicated, it seems, and that's nice. Now, there's something else they talked about here that's interesting. Lumps of matter in between other places in space and Earth could make it look like there's an acceleration when there isn't one. This is called gravitational lensing, and although this isn't actually a lens that brings something closer, gravity can warp and twist and bend light, and it could give an optical effect. It makes it look like the universe is expanding when it really isn't expanding as fast as we have recently calculated. But that's kind of grasping at straws. That's probably not the answer to this hypothetical question. Let's see. Well, I guess the whole point of this is really to talk about how space and science and all of these thinkings, I just think people are getting a little bit on a long leash with these hypothetical things and running away with them. And that's not very healthy in logic or science, and certainly isn't healthy in theology or religion when people run way beyond, for instance, what the Bible says or true, valid biblical experiences with God. How about true, valid experiences with the universe through a telescope? We need to stick to data. Science needs to be data driven, not theory driven, not imagination driven. Oh yeah, theories and imaginations lead to the collection of more data, but often that data should revoke wrong theories and should bolster new ones instead of desperately reaching out and adding things to the universe and making stuff up to try to make 2 + 2 = 5. That's a problem that scares me in science because it's a sign of society and even our trusted scientific community going just a little bit crazy. Well, hopefully on that high note, I can still say Merry Christmas to everybody, and I'll see you after the holidays for a little bit more thinking with Dr. Jackson on points of origins. Merry Christmas.